Okay, bad news. Miro is undergoing this maintenance, so at this time it's not working. I can only show it, but I cannot write. I cannot do anything else. Okay, so
So you can print and copy.
oh yeah, I think I got for you.
You talk in the Sorry.
You bring your Eno salt.
Yeah, that's what I forgot to bring.
You bring your salt.
Oh shit.
Okay.
Wait. Set reminder it didn't pop out.
Oh. Okay. Then can't do anything
Mine is okay.
unless I have some leftover salt from long ago. But salt, I'm a bit scared. I prefer Eno, which is safer.
Yeah.
Okay. Anything? Simple question. How do you recognize between electrolysis and simple cell?
Like the battery and the is it the circuiting one?
Which one has battery?
What?
Battery.
Oh, I was asking her, actually you also,
Ah,
how do you tell between electrolysis and a simple cell?
electrolysis got battery.
Yes. So that is the important answer. Because you have to look at your question and already you must tell the difference. So anyway, I drawn it last week. At least can still see, but I cannot write anything. Electrolysis, where's my pointer?
We'll go into poly now.
Cannot get into GC, I'll go for it,
So guys, look at your question carefully. All right, here it's very obvious. I drew the battery out, so you won't mistake it. But in your question, they may not draw the battery. Especially all your teachers are chemistry teachers, they're not physics teachers. They're not going to draw this out for you. You have to look at your question.
You don't know.
Yeah, but don't know how to draw. All right, but simple cell. Simple cell is a battery. Itself is the battery. Okay.
Yeah.
Okay, now, last week I was going to tell you something very, very confusing. This one. Now, look at this. This is electrolysis. I think all agree, right? Positive terminal, negative terminal, or positive electrode, negative electrode. You remember the word electrode, right? Can, because it's linked to positive, it's linked to negative. Can, but also we have, before I say the but, let's continue. Remember the two words cathode, anode. Now, anode is always oxidation. It occurs on the anode. Cathode is always reduction, whether cell or electrolysis. It's always true. Remember that. I think there's a name for it, but I can't remember what's the mnemonic. Because I don't need to remember that, so I hardly use the mnemonic. Got mnemonic or not? Meeting.
For what?
Anode oxidation, cathode reduction.
I don't know.
I can't remember the mnemonic because I don't need to use the mnemonic. A and O. A and no something. I can't. I need to check it out. But for now, just remember that. But look at my this one. This one is tricky there. This one, do you still have your drawing from last week? Looking for single cell. I didn't mention it last week, no. Where is positive and where is negative? I didn't tell you the answer last week, but are you able to figure it out?
Left side positive.
Left side positive, okay. Why do you say that?
Current flow that we have.
Oh, no, look carefully, Jingqian. What's my current flow? Oh, this is electron. This is current.
Oh.
But you're on the right idea. Guys, add into your notes. Current flows from positive to negative of a battery. So positive is on the right. I mean, based on what I'm drawing, negative on the left. Because the whole thing is a thing of this whole thing as a battery. And you, from your physics, you know that electrons flow is opposite to current flow. So those who don't study physics will have a slightly harder time to understand this.
Good.
So what do you notice? On this side, negative is cathode. On this side, negative is anode, no? That is the super confusing thing. Every year, some students will mess it up 100%, even in polytechnic.
Oh, no.
They will mess it up. So you have to know whether you're looking at electrolysis or a cell. But Minky, any question?
No.
But as I said many times, anode is always oxidation, cathode is always reduction. For both of them. Okay? For both. Anode oxidation, cathode reduction. Oh no, I can't remember the mnemonic already. Okay, let me see. Anything else I need to tell you? Look at this one here. Oh, before, just to clarify, the current is going through here, so yeah, of course. Otherwise, how to have a complete circuit? Current is going through here. How? How does the current flow there? Is a solution, right?
Magic.
Magic. For upper set, you can't use the word magic anymore.
You even use it in school.
Hey, you can use that in primary school, I know. Remember, the key is it's a movement of something, but it's not the movement of electrons. This is the wire, right? This is a wire. So electrons are moving. But this is not a wire. So what are moving? Cation and anions. Okay. So the current flow is due to the movement of ions, not electrons. Oh, okay, I'm just saying this for the sake of Zayden. Zayden, sorry, I can't use a mirror to draw anything, so just try to follow my arrows. Question or revision. Ions will go towards which side? This or this?
Yes.
Yes, very simple to remember. It's true for both cases. Cations go towards cathode. and ions go towards anode. Can I?
Ion is negative.
Positive.
Oh.
Don't mess that up. It's always true. Cat ions go to cathode and ions go to anode, which is why they're called cathode and anode. Always true. But look at this whole list here. So you know what's the problem? Or not problem now. I mean your task. When you're given an electrolyte, you have to figure out what are the electrons, what are the ions inside. I'll give you an example. I can't draw on this, so I have to switch my screen.
You can use paint.
Yeah, that's what I'm doing.
You are going to read equations from equation with
Okay, let's see about
Oh, it's AR.
air resistance.
Oh.
This was I thought this was in just now.
I don't really stop.
You get the hang of it. Okay, guys. So therefore, I'll ask you. Let me. I haven't activated my stylus. Now, let me ask you. Let's say I have this. Let's say I have this.
You can't do equation one.
No, I give you this electrolyte.
If you minus it, right? Yeah, I know.
Just ask yourself, can this conduct electricity? Well, answer is yes. Because you have ions inside. Next question. What ions? Okay, let's be systematic. Somebody tell me what are the ions?
Into plus.
Any?
Plus.
Oh, plus. Sorry.
Any plus,
Right.
There's more.
Any ions?
Minus.
Anything else?
Still?
Still important.
Yes, AQ is water, no?
No.
So what should
H plus. O2 minus.
Very good. Right in. H plus OH minus. So be very careful. What is your electrolyte? So next, I put in my electrodes. Now, you notice the battery there. So this is electrolysis. Next question. Which one is anode? Which one is cathode? Of course, you can refer to your notes for now.
Cathode is the left side.
Good. Good. Jingjian, okay. Anything why? How do you know?
Negative to positive. So it has to be cathode because positive ion.
Yeah. But of course, you know that this is electrolysis, huh?
Yeah.
Don't look at the wrong side. Huh? Don't look at the wrong diagram.
Can then like say flip the battery.
Flip the battery, yeah.
Yeah.
I mean, of course, I can flip the battery, then the anode will be left, cathode will be right.
Okay.
Can. So that's why the battery is important, the direction. But chemistry usually they don't even draw the battery.
Ah,
They just tell you, oh, this electrode is negative, this electrode is positive.
Oh, they tell.
They tell which one is negative, which one is positive. Because they are not, unless they're teaching physics at the same time. Otherwise, they don't even know how to draw the battery.
what? Serious?
They don't do it often, also they have forgotten how to draw the battery.
Excellence.
Okay, so therefore, I would expect, let me change the color. Okay, I would expect my Cl minus to go here. OH minus will go here as well. I would expect my Na plus to go here. H plus to go there, so cat ions to cathode, anions to anode. That is always correct. Next question. Which side is reduction? There goes your 2 marks, 3 marks.
Oh, get that.
Okay, always remember cathode reduction, whether for cell or electrolysis. Thinking, once you have found out what the mnemonic is, let us know. Or Jingjie, if you have found it out, let us know.
Mnemonic for?
Cathode reduction and no oxidation.
It is.
Yeah, I think there's all sorts of. I don't know what
Like
I
in
don't want to use the
textbook?
word silly lah, but
In textbook.
no, not in textbook, unofficial. Okay, for textbook, there's this oil rig. I don't know whether you come across this oil rig before. It's quite silly because oxidation is loss, reduction is gain. But they didn't tell you loss of what or gain of what. It's actually gain of electrons and loss of electrons. But you may not remember that. Anyway, it's up to you whether to use it or not. But of course, for me, I don't need it.
Textbook and man.
This one got, I think oil rig, there is oil rig. Maybe your version doesn't have, the older version has it.
Oh.
Okay, but next question. Now we have a problem, no? I have 2 different ions at each electrode. Who is going to get reduced? Who is going to get oxidized? Okay, that is your question. That is your question. Think carefully. Now, to answer that, look at your worksheet that I've given you. Go on, I need to change my screen again. Okay, so that Zayden can follow along. But look at this portion. You see a list of ions, cations, and anions. I want you to look at this word, discharge. Now, discharge can either be oxidation or reduction. That's the meaning of discharge.
What?
Discharge can either refer to oxidation or reduction,
Oh.
depending on the electrode. Now look at cations first. Where is sodium at the top? Where is H plus here?
So the one at top.
No, look at the arrow carefully. The one at the bottom will discharge. So H plus will discharge, because H plus is below Na plus. Whichever is further at the bottom will discharge. So by the way, do you notice this sequence looks like what? It looks like your
Oh, metal thing, right?
Beyond reactivity series,
Metal.
stop calling me a crazy zebra. Yeah, but of course they miss out a few other items. But if you follow the same order, no? So that's why, guys, try to remember your reactivity series soon.
Soon.
Or now.
No, can.
Huh? Every night you just recite stop calling me a crazy zebra, instead learn how copper says go. Okay, have fun.
You also know yours.
Why?
I have to go memorize where stop where pause.
Oh. Now, this one is a bit harder.
Okay.
What pattern does it follow?
Nothing. No bad.
Unfortunately, there's not exactly a pattern except for this four. 1, 2, 3, 4. What are these four? F, Cl, Br, I. They are the halogens. Groups 17. Look at your periodic table. You need a copy?
Come on, can.
You have it? Yes.
Periodic table.
Oh,
Oh, it's in order already.
yes, it's in order. Most reactive is at the top. Least reactive is at the bottom. F down to I. But
Oh, okay.
okay, can only for those four, unfortunately. OH, you have to remember, is all the way at the bottom. So, go back to here to answer our earlier question. Sodium or H plus, which one discharges? H plus.
Yeah.
So H plus gets reduced. Remember, at the cathode, it gets reduced. How about this too?
Okay.
OH minus gets oxidized. Can, okay? But you have to write out the equation too. So let's go back to. Okay, sorry, I need to change my screen again.
So you can't always share screen, right?
Share screen. How to share screen?
What?
Because I have to switch the screen so that when I'm recording now, so that I can record the correct screen. Otherwise, they don't know what I'm talking about. Okay, come, let's go. So who gets reduced? H plus. Where's my cursor? Who gets oxidized? OH minus. But it's not good enough. You have to write out the equation. Okay, that's when your oil rig comes in. Reduction is gain of electrons. Reduction is gain. So this will gain electrons. So electrons on the left hand side. So what does H plus become?
H.
You can't really have H on its own.
H2O.
Yes, good. So I need balance, 2H plus. I need 2 electrons.
Can you just write electrons like that? Oh.
It's internationally recognized.
Okay.
Well, of course, guys, you need to do the same for OH minus 2. Of course, it's on the left-hand side. So it gets oxidized. Therefore, my electrons are on the right, obviously. Okay, because it loses electrons, so electrons are on the right-hand side. But what does OH minus become?
Oh. 2 minus.
No, if you immediately give you O2 gas.
And H2.
Good. And if you don't forget to balance it, you need H2O as well. Okay. But it's the whole equation is still not balanced yet. Come, how do I balance it?
On the side,
Okay.
2 on which side?
left side.
Left side, yeah. Think carefully.
4.
Is it?
4.
Where?
Left side.
Okay, excellent. Right hand side.
Initially, right?
You notice I have 4 minus charges on the left.
Oh, sorry.
So who has minus on the right? Who is negative on the right? Only electrons are negative, no? O2 is neutral, H2 is neutral. So I need to put a 4 here. Okay, to balance the 4 negative charges on the left. But I'm still not done yet. What else?
Put 2.
Where?
H2.
Good, good. This is a standard equation. If you want to, remember it. If not, make sure you know how to balance it. Can I? So, okay, I'm not finished yet. What do you observe? Because you didn't bring your socks, so we can't run this experiment. But what will you
So you
observe?
want me to go sing some?
Later, like this time. Come, what will you observe? O2. Come, write out the state.
Oh, the gas will be produced, then got some shear.
If you see effervescence, all right. And where would you see effervescence on both sides? I hope you realize that. So can you write down your observations? You will see effervescence on both sides now. You need me to write down? Please write down yourself because it can be a question. What will you observe? Can? Okay. But I'm not done yet, no? Okay, occasionally, this may not come up. However, it has come up before. Look carefully. This side, use the pointer. This side only 2 electrons. This side is involving 4 electrons. Okay, so you need not do this. This is more for demonstration purpose. I just show it to you only. Now, let's say I convert this to 4 electrons. Oh, sorry, 4 electrons. Okay. Okay, agree. So this is take it as equation 1. Take this one as equation 2. And if I add equation 1, like max like that, plus equation 2, what do I get?
3.
Equation 3. I guess this.
You know. Equation 3.
Equation 3, yeah. Yeah, it's equation 3. But you have to express equation 3 outright.
Wow.
So it's going to look like this. 4, 2, 1.
Where did the electron go?
They cancel each other. Sorry, H2, H2. Am I correct?
Yeah.
Did I miss out something? I want to let you double check. Am I correct?
Where I think.
2H2 plus O2 plus 2. No, I miss out some. How come it doesn't balance on 4? Okay, yeah, it doesn't. 2 times 2, 4, 2 times 2, 4. Yeah, correct. But I'm not done yet. Can you try to follow? Now, my left hand side can also be written as 4 H2O. Okay, then what? I can cancel my H2O on the left and on the right, huh? So if I cancel them out, I will get this final equation. Okay, I want you to write this down. There's a name for this. This is the overall equation or overall reaction. You remember in your primary school, you can use electricity to split water, or maybe lower side split water. Split. That means you use electricity, it goes through water, it converts to O2 and H2. That is this one. No?
Oh, I get it. I get it.
I want you to write down the overall equation, or sometimes we use the term overall reaction. Because your question may ask you to do that, no?
So this is my thing.
But you can't remember every case, no? This is just one single case, right?
Oh, oh.
This is just one single case, no? Okay, then, all right, so, okay, guys, lastly, I want you to interpret the question because the question will be very specific. So, this equation that I've written is called the cathodic reaction.
Yeah.
So, if they ask you to write the cathodic reaction, this is your answer. Of course, the other one is called anodic reaction. Lastly, if the question wants you to write the overall reaction, this is the answer. Now, reminder, in case you didn't notice, for cathodic and anodic reactions have electrons inside. Okay, keep that in mind. Overall reaction should not have electrons. Okay, that's just one case.
No.
Now, how many cases are there? You want to know?
There's confirm like
9.
everyone.
Let's see. Where is my mirror?
10.
Yeah.
Okay.
1, 2, 3, 4, 5, 6. Okay, not too bad. 6 standard cases. However, since you're impure, they can give you some funny cases that you've never seen before.
So bored.
Five.
And you know your teachers well,
5.
but 6 standard cases. In case you want to mark it up, so far I've only talked about case number 2.
Oh, there's molten. Oh.
Yes. There's concentrated also.
What? Oh.
There is copper sulfate too.
Okay.
Yeah, because the electrodes are different.
That choose the. Okay.
Then, so okay lah, only 6 cases to remember.
Still long.
Molten and garden.
What does the word molten mean?
It's liquid.
Yeah, liquid. But that also means it's melted, no?
Melted.
How do you get a liquid sodium chloride? Because it's melted.
You melt. You
Then the temperature must be high, no?
1,000.
About what, 800 degrees Celsius?
Oh.
Or is it 1000? I can't remember the exact number. It's pretty high.
No.
No need to know lah, for fun, ma. All ready to go.
Until that's flexing.
Uh,
This one.
Okay, let's turn to a new page. Okay, after a while, you get the hang of it.
Okay, your after a while is like many years now.
Maybe not.
You don't have many years. We have a few months.
Okay, now let's look at molten. It's very easy. Remember high temperature.
Oh,
Temperature.
it's so hard.
Page number. Okay, up to you to number yourself. First question. Is this an electrolyte? Yeah, of course it is. It contains ions, right? What ions are there?
Same lah.
Not exactly. There's no water.
Oh yeah.
Only two. So no need to choose already. You don't even know. It's good, no? If you see this, you don't even you need to remember that list.
Dangerous.
Okay.
Nothing to choose.
Let's go.
So same thing, I give you your electrodes.
What is it?
Which side is anode, which side is cathode?
I told us
Look carefully.
Oh. Oh. Why?
Don't get tricked,
Why you switch it off?
to trick you.
Oh, okay, fine.
Okay, so of course, nothing to choose. What happens to Na plus? It gets reduced because it goes to cathode, remember?
Yes.
All right. So how does it get reduced? It take in electrons to become what?
Any.
You know. Oh, just in case this is a liquid. Obviously, the temperature is very high, right? So Na will be a liquid too. Same thing, can you write the equation for the other side? You only have Cl minus, right? It's going to get oxidized to what?
Yeah.
Cl cannot exist alone.
Self
Cell two.
Don't forget that.
to remove.
Balance it.
Two.
What? What state is Cl2?
Yes.
It's a gas, okay.
Okay.
Remember, long ago we have gone through the periodic table. What are the states of matter? But of course, at such high temperature, Cl2 will gas.
I don't remember anything.
So it's just a gas.
No. I only remember like Cl2 is gas.
Okay. At least you are not guessing. Okay, can. So yeah. Now, question why do people even want to do this?
You don't get poison.
They want to get Cl2 gas and sodium metal.
Cl2 for what?
Oh, Cl2 can be used for other reactions to produce like plastics, acid, Cl. Okay. Can in case they ask they can ask about that. What's the function of doing this thing?
Yeah.
How about this one? Why do you even do this? Because you want to get pure oxygen and hydrogen.
The overall reaction.
Yeah.
Situation.
Okay. But it's an expensive way to do it.
And
Expensive. So
Because
that's cheaper.
yes.
No
Because this uses a lot of electricity.
so we just look at the overall equation and then we see what the other get.
Yeah. Okay, let's go back to the second case I'm going through. This one is so easy, no? Nothing to decide. Once again, label them. This is your anodic reaction. Cathodic reaction. Now, of course, if you want, you can write the overall reaction as well. Remember, there's another way to actually determine what's the overall reaction.
Yes.
What is my electrolyte?
And
Yeah, NaCl. And what are my products?
Two
And
and a
yes. So I can also determine my overall reaction in this manner, no? Without like plus equation 1 plus equation 2. That one to me is quite cumbersome. But of course, as usual, balance.
So both ways work.
Yes, this is the simpler way.
Can still also work for
Yeah.
any question also.
Okay, go back to just now at case 1. What is my electrolyte? Yeah, this guy.
yeah.
Oh, no. Sorry. This one doesn't work that way. You have to look at H2O. Okay. H2 is in the aqueous form. What are your products? H2 and O2.
Oh.
Okay, so that's how I can write the overall reaction. But don't fall trick, don't go and write NaCl.
Why? Why do you
For this case, they are interested in the water rather than the NaCl.
Hey.
This is a painful chapter.
But we need balance, right?
As you have to. And okay, third case. You can draw your own if you want to. Come write up yourself, draw yourself. What are the anodic reactions? What are the cathodic reactions?
What's the term?
Concentrated sodium hydroxide.
Not the control.
Why doesn't you draw? No,
Not dropping.
it's fun.
Fun.
Fun to draw. That's why I like Miro. It gives you a chance to draw. Draw out, write out. I drink some water.
You know let us draw the mirror.
Why is it Cl2 and H2 now?
Okay, this one is the worst case. Or maybe not. But one question, where can you find concentrated NaCl?
Yeah.
Yes, of course, you can make your own. There's a name for that. It's called brine.
What?
Try to remember this word. Brine means concentrated NaCl.
I can't remember that water. I said remember.
Why is brine a recipe?
But yeah, you're not wrong. You make it in the lab or in the factory, you make concentrated NaCl. But the other less, I would say, the other way which introduces more impurities is take seawater, you evaporate it.
Oh.
Then you get brine. But of course, you don't vaporize all the water. Same thing, please add in your electrodes and your battery. Okay, now the thing is this. Of course, as always, like for me, I like to label where's the cathode, where's the anode. cathode. Okay, now what are the ions present?
Plus.
Same thing, Na plus, H plus, OH minus, Cl minus. Yeah. Same questions, who is going to get oxidized, who is going to get reduced? Oh, oops. All right, too bad. I didn't look at this, didn't change my screen to this. Too bad. Okay, where's my? Yeah, look at your list again. Where's my Euro block here? I think it may be ready now. Now, come. They are still the same, right? I mean, obviously this list remains the same. I compare sodium, H plus. Wow, they are so far apart. H plus will still get discharged. Okay. Equation is still the same. You form H2. But here, where is my Cl minus? Here. OH minus is there. They are not that far apart. And remember, I increase the concentration of Cl minus and Na plus actually. So as a result, I can force Cl minus to become discharged.
Force.
Yes, by increasing its concentration. But it doesn't work for Na plus because Na plus is too far away. The difference is too great. Next time, if you study A level, they'll tell you the values for each of them.
No,
They have values, actually, numbers.
no A
No
level.
A level.
No.
Oh, okay. Also, go back to my diagram. And for Zayden's sake, let me just change my screen again. Where is it? Okay, come. So, H plus still get discharged. As I said earlier, reduction, cathode, reduction, so I'm not going to write everything now. But at least you must write the equation out. Now, because it's concentrated, Cl minus is forced to become discharged, so you will get this.
So if it's concentrated, then
There are equations for that also. You calculate the concentration and then plug the concentration in
you have to know.
only for A levels. Okay, so job done. Now, for this case, you can't really write an overall reaction.
Good.
Situation.
Very good. Very good.
Oh, but reminder, guys, this is a rare question. Cl2 is poisonous.
Yeah.
That is why. Oh, let her finish my thing. Yeah, that is why I prefer to use eno salt rather than electrolyzed stable salt. Because stable salt has a chance of producing Cl2 if your concentration is too high.
Yeah.
Whereas eno salt is not sodium chloride, it's something else.
They sell no salt here.
Huh?
Do they sell?
Should have.
Okay.
Oh, by the way, in case you ask what's eno salt, it's magnesium sulfate.
Oh,
I'm just.
Look at magnesium and sulfate. Come, where are they? This is not a standard question, but well, it can come up for you. Come, where's sulfate? Right at the top, no? It's almost impossible to discharge sulfate, no? Whereas where's magnesium? It's also pretty high up. It's not easy to discharge magnesium. Anyway, I'm not too worried about magnesium. I'm more worried about chlorine. Or for that matter, bromine, iodine. So don't play with this Q. 1, 2, 3, 4.
all poisonous.
All poisonous. Oh, actually, you can also discharge sulfate, but you need very extreme conditions.
Which is.
Very high voltage.
Do you know?
Cannot. You can't do that.
Yeah, of course. And don't worry, they will ask you for O levels. Probably not.
So
If you discharge sulfate, you get SO2.
oh
Which
shit.
is poisonous too, by the way.
Why are you think poisonous one time?
Yeah, lor. Safest is OH minus and H plus. And happy.
The oxygen is in.
Hey, come guys, you want to draw for the
Others.
last 3 cases?
No.
2, 3.
One, two.
Oh, it's 5 p.m. but Miro is not up yet.
What are they doing?
Yeah, I don't know. Let me restart Miro.
For the whole day already.
Oh, no. Only 3 o'clock.
Oh.
Too bad. It happens to be your lesson.
Yeah.
And Angel's lesson.
Oh. This one.
Yeah, still not up yet. Oh, I can't even go back to the screen already.
This is.
That's a glitch.
Oh,
What is maintenance?
Oh,
What's wrong with that?
crazy.
It's been 10 minutes.
So I think you,
Fine.
you close the entire video, then you open.
Maybe. You think it work?
You try can.
Then everything is gone.
Really?
Doesn't it save itself?
Hmm?
It save itself,
No, it
right?
should save itself. Oh, see, it's hanging already. Yeah, glitch.
Wow.
So cannot.
So,
Yeah.
Okay, come on, Jingjie, continue drawing for the other 3.
Oh.
what was it now? Do we use it?
Oh, yeah. Oh, yeah. I can't see my. What is one?
CuSO4.
Okay.
Lithium.
Yep. Try CuSO4 equals. Yep. Follow the order. 4, 5, and 6. Follow the order in your table. Oh, guys, I didn't highlight it, but look at the first 3 cases. What material am I using for electrodes? Yes. Carbon is also graphite. Make sure you recognize it. Your school can use the word graphite too.
Flash.
Graphite.
Yes.
The graphite is like damn weak. How are you gonna use it?
Weak. Is it weak?
I don't know.
It's okay.
Okay.
I also want you to write graphite or carbon is relatively inert
What is that?
because you don't want your electrode to react with anything else. Obviously,
It's inert.
it doesn't react. It's not reactive.
But inert.
So of course, how to spell inert?
Like emotion, right?
I write on the board.
Is it?
Oh.
Better know this word, you can come up to. Oh, they can also ask you, why use graphite electrodes? That's the answer. You do not want it to react with anything, no, like electrolyte, products, or reactants. And of course, they have high melting point. You don't want the whole thing to melt halfway, right? Especially molten sodium chloride is high temperature, no? Don't forget.
Oh yeah.
No. So you would have CO2 plus. Oh. H plus.
I forgot anything.
Carbon use.
No, it's a regular occurrence. Every 2 months, I think they will have a maintenance session.
For how long?
Standard 2 hours. Why? Good question. I'm not in IT, so I'm not too sure. I mean, next time I go in IT, you know.
Me.
Yeah, IT. coding. Okay, guys, draw for the other three cases. Let me try to look in the mirror.
How did you get O2 out of nowhere? Oh, I'll get it out now.
Okay, guys, remember O2 is always from OH minus, H2 from H1.
So we add with OH minus and H plus.
Okay. Number 4.
Is it? No?
No. Number 4, be careful. What cations do you have?
CO2 plus
CO2 plus and
SO4 minus.
cations.
H plus.
H plus,
Oh,
Look at your list.
yeah, I got that. All right.
Look at your list. Who is going to get this one?
Oh, CO2 minus. Also back minus. Sorry.
Don't get tricked.
Oh damn.
So it's reduction
So CO2 plus will get reduced.
in electrons.
The right equation.
Yes, also always
Such a
write the electrode reaction, write the overall reaction.
minus.
OH.
So you just never see you. Or the
Yeah, good. Cu2 plus 2 electrons becomes Cu.
policy.
But write the states. You don't need it to be molten, right? So the states are just the normal states. Make sure you get the state symbol correct.
Normal state. AQ.
Yes, AQ, of course, copper. What state is copper?
What?
Copper?
Copper.
Copper 2 plus is AQ, right? It becomes copper, right? Copper is what state?
It's solid.
Yeah, sorry. So you have to remember your states. That's why I've gone through with you previously.
Let's copy the top.
So how about anions? That one should be obvious. Who gets discharged?
OH.
Yes, of course, OH. And the equation is the same.
U and
This one got overreaction.
This one, no. You can't write the overall reaction.
Yeah.
However, I want you to write observations. What will you see at each site? Anode, what do you see? Cathode, what do you see?
no. TFL person.
Yes.
Okay. Then what do you see? You see precipitate. Solid.
I'm a bit hesitant to use the word precipitate because it implies a precipitation reaction. But you count as precipitation reaction, not necessarily.
Solid.
No, you just say solid copper forms. But don't forget, solid copper is dense.
Close.
Yes, if you fall to the bottom of the composition.
Next.
Oh, one other thing. What color is copper?
Black. Nah, brown.
Brown.
Yes, you can use brown. So sometimes your question will tell you brown deposits are found below this electrode. So the first thing that you should think of is copper. However, pure copper is not brown. What's the other answer for pure copper?
You know.
Great.
Write down, because this can come up in your question. Pure copper is pink.
Pink. Without green.
What the shit?
I give you the copper piece, you go home and polish until very pure, then you see pink.
Actually, we don't have time for this.
Okay lah, yeah, anyway, you don't game lah, you game polish.
Don't game.
So in pink
Wow.
or
Be very sensitive to the word pink.
Just still looks brown. Pure copper.
People have described that color as pink. So if you see pink in your exam question, don't be surprised. It's pure copper. But just now you say black. What is black?
Carbon, ah.
Yes, anything else?
You know,
Okay, you all better know. It's quite common.
charcoal.
Copper oxide. Copper oxide.
I keep saying that, then I also forgot.
It has come up many times. So of course, if you forget it, that's fine. Hopefully it doesn't come up again.
Copper.
What color is that?
What color is what?
That,
Pure lead.
yeah,
Lead metal.
yeah.
Lead metal. By right, it's grayish.
I supposed to remember all this.
Some of them, especially copper.
What?
Colors.
Colors.
The worst is iodine.
Oh yeah, you got brown, got
Violet.
purple. Violet,
Violet,
okay.
black, brown. And you have to remember what conditions is what color.
Oh my days.
I mean, you find that you're already having a lot of things to remember, and then you get it like, hopefully it doesn't come out.
Maybe I don't start remembering the Sec 3 stuff already. So when later on they do like revision, that'll be easier for me. If not, legit cannot.
Because I personally, I would advise you, unless you have spare capacity in your head, otherwise colors, except for a few important ones, most of them you just let it be. I can remember it because I've seen it before, I've used it before, so it's easy to remember.
Easy to
But for you, you haven't even seen it before. Have you touched it before or not? Never.
God, the mouthwash.
Okay, unless you remember that one.
Thank you.
But purple, you better know. If you see purple solution, what is it?
What? Well, I thought you said iodine.
That one is quite rare. It doesn't come up often. It's very rare.
Solution.
But the common one, what is purple? Purple solution.
The 7.
What 7?
I can't
Hey, you better know. This one can come up for your practical.
It's the magnet or something.
This one, they got the this one.
7. 7.
Purple solution.
That's 7, right?
Yeah, 7.
Steve.
Better remember this one. I mean, other than that, iodine, if you can't remember, I'll forget it.
Okay.
Okay, well, I still haven't gone the zero yet.
Then you forgot password.
Yeah, I'm trying to find my password.
Just reset.
Instead,
Yeah.
no, I guess can take a lot of time.
Really?
What? CU and dissolves.
Okay. I can't even go in. Miro is still not up yet. I can't even try to log in. Okay. Never mind. I'll get my original copy. You just hold on. Okay, guys, can you draw case number 5 as well?
Why is it copper?
Okay, now look at case number 5. Electrodes are copper, no? Both sides are copper.
Why?
Because you want it to be that way. Oh.
Ticket.
Question was there.
Yes, the question will tell you unless they want you to find out what is the electrode? Because they tell you the reactions and they ask you what electrodes are used. Troublesome, right? Hold on, let me deactivate my thingy first. My background. So that I can write on the board. Okay, come. Now look at case number 5. Okay, case number 5. Now, okay,
Anode.
as always, what is here? What is going to come here? Your anion. Okay, this one is obvious. Look at your list. This guy is going to get oxidized. Okay, I'm not going to write the full reaction, but it's the same. Same thing, I write what is going to come to cathode. Now, if you look at your list, this guy will get discharged or this guy will get reduced. Fine. This guy is a cathode. I mean, this one is copper. Okay, so it changes the probability already. Because this guy is a copper. It gets discharged instead. But of course, please write your reaction correctly.
Wait a minute.
And a lot of times, as I said, your copper will sink to the bottom, and then you get a par layer. Sometimes in your exam, you use the word round deposit as a bottom.
KM step is even very direct. Yeah, it's right.
Okay, so you better recognize what that means, huh? Okay, that's case number 5.
The last one looks weird.
Yes, the last one looks a bit weird. Oh, hold on. Okay, I forgot something.
Wow.
Hold on. Can you? I missed out something. Can you go to case number 4? What electrodes do they use? Case number 4.
Click the red number.
There and
Case number 4, they write platinum, right? So platinum cathode and anode. Can you add in? Why is platinum?
else you want to.
It's very, very inert, but it's very expensive. Very.
Oh, it's
Okay, yes. I don't have one for you, otherwise you take it home.
ah, why would I take you home?
I have a, you know, a satay stick, right? Satay, a
Ah.
stick.
Mm.
If imagine the stick is platinum, it will be about $1,000. More
Silver
than
one.
$1,000.
Is that shit?
Is it
You will
silver?
relook.
I know. Okay.
You have one at home.
No, no, no.
It's too
Very-
much.
I saw before.
Just a tiny, I mean, not tiny, but thin stick like that, about more than $1,000.
Is it because it's very hard?
Platinum is a precious metal. It's almost as expensive as gold, no? Almost. You
Damn.
can look for platinum jewelry also.
There
Is
is.
it in jewelry shop?
Yeah.
The silver one lah.
Yeah, the silvery color one, but no, it depends also. Some silvery color one are actually
Silver.
gold, white gold.
But
This white gold.
Yeah, they add something inside to make it white.
I think so good.
Fashion.
But let's go to number 5. I forgot something. Sorry, I forgot something. Look carefully at your table.
Mm.
Both are copper. No? Copper,
Yeah.
copper. Okay, I missed it out. So sorry, this is wrong. Oh,
What does it mean to be copper?
because this big guy here is copper. This guy will not get discharged at all.
Because it captures.
So nothing happens.
If you take priority, no, something happens if you oxidize.
What? What the heck? Oh no.
So the nature of the electrode affects what you get discharged.
Memorize.
Unfortunately, yes. This chapter, I don't like it because there are so many new things, but the weightage is not that high.
That's great.
Good.
So I would suggest you study the last for, let's say, your final prelims exam.
Okay.
So can you like give this chapter of the organ?
I can tell you straight lah. Organic chemistry,
First.
highest weightage.
So study
But
that.
unfortunately, it's the last topic to be covered in your school.
They confirm like
And
rush.
here also lah.
Huh?
Why? It's
But I try to follow your school first one. You don't want me to follow your school
okay.
first.
Oh yeah, the schedule thing I don't get it.
Never done. Never done. We'll follow the schedule then. Oh, lastly, if you see electrons on the right, it means it's an oxidation. This one, electrons on the left, it means reduction. That is one way I differentiate. Okay, I'm not done. What other observations? You have to look at both sides now. What happened on both sides? Copper is becoming copper 2+ though.
Yes.
Huh?
Yes.
Which one is a gas?
No, I think.
What happened?
Right down. I won't use the word slowly.
What is AQ? So that's water.
Oh.
Okay, take note. That electrode becomes smaller and smaller. Because it's dissolving, huh? But of course, I forgot to get you. Ten. Okay, last case. Oh, you haven't drawn yet. Last case.
What then?
Number 6.
Oh, not yet.
Number 6 is weird.
Joe, what did you draw just now? What
Hmm?
did you draw just now? Oh, copper body. Okay.
Now, number 6.
And
And why is it right? This one is, oh yeah, troublesome.
Will come out.
Huh?
Will come out.
Oh, yes, yes.
像还有像
Possible. No, actually, all these have equal chances.
哎呀，
Unfortunately, you can have some funny cases too.
I got gold.
Yes. Some schools have used gold.
Oh, hang on.
Is it your school?
No, not possible. School is broke.
A broker.
They can't even afford. They spend all the money on the facility, right? They just spend money on the aircons.
But no lah, they don't use gold in your experiment. They use gold in your question.
If you go experiment, people all take gold.
Yeah, you all pretend, then want to wash, right? You keep some in your pocket. That's why I don't have the platinum rod.
Wow, you don't trust the.
Too expensive for me.
Ah,
Right now. Now, because this guy is copper. Because it's copper, it gets oxidized.
It's very good. I think you should get, yeah, like
it's
the
called.
amount of phone.
Now, because this is not copper, this is carbon. So what is that? Same thing, no? What is over here?
OH minus.
No.
Oh, okay,
Because this is not copper, this guy will get reduced according to that your table here. Hold on.
Wait, here two percent on top of.
No, it's the other way around. Why do I say that?
Oh, okay.
You and not.
Okay, sorry. It's still the same. Actually, it's still the same thing. It's still the same thing, but
Evaluation is really useful. Maybe if I want to find like the chip and down the next that after you divide the name like
I think there's something. Never mind, you're right now.
Wow.
Oh no, I forgot something. Because I haven't done this for some time.
Oh no.
I forgot something.
Wow, so
Can you erase this for number 5?
use pen right?
Oh,
Or that portion.
You did?
cathode. Now, what is this? I forgot something. Let me use a different color. Because this copper, right, number 5.
Yeah.
Now, copper 2 plus become copper, right? At this side.
Yeah.
That's the direction, right? At this side. Now, this is copper, that is copper, they like to stick to each other. Yeah, they like to stick to each other. So therefore, typically it won't drop down. Oh, it's thick. Yes, it will become thicker.
Opposite, huh?
This is your observation.
Open your eyes and read your question. Like, I want to like, there's I'm not really young. Yeah, right. It's like some, is there something?
Now, for this one, number 6, this is where it may drop down.
Because it's not copper.
Yeah.
Oh,
The other way.
But I'm not done yet. Number 6 can have another possibility. I hate it, but hopefully it doesn't come up, even though it has come up before.
Why is it?
once every few years.
Because this is carbon, remember? Does metal like to stick to carbon?
Does it?
No, not really. Remember carbon, graphite, what are the bonds inside?
Okay.
Graphite. Graphite.
Carbon.
What bond?
I don't even know what it is.
Hexagonal.
Covalent.
Yeah. Yeah, it's a tetrahedral structure, but it's covalent bonds. What bonds are inside copper? Everyone has forgotten.
Copper bonds. Ionic. No, covalent. Then what? Oh, it's the metallic.
Can you remember metallic bonding? So a substance metallic bonding doesn't join well to a substance with covalent bonding. It doesn't. However, that was carbon. Let's say I change it. This can come out, unfortunately.
Change to covalent.
No.
Confirm something that the lights.
Big bond.
If I put an iron nail there, or steel nail, iron is still predominant, or steel is still predominantly metallic bonding, right?
Yeah.
Right?
Yeah.
Then I have a different story. My copper can stick now.
Why?
Because both are metals, the bonding are what should I use? Consistent.
Can one draw?
So what happens is, in this case, this is the iron electrode or steel electrode. Yeah.
Becomes thicker. Or coated. Not thicker.
Yes, it becomes thicker too.
Yeah.
No, you need. So you get one.
So unfortunately, this case can come out too. So a lot of things to remember for this chapter, even though for that small weightage. Not to mention, even that to fit this thing here, you need to spend some time to look through, to remember as well. But of course, the left-hand side is your reactivity series, which you have to remember sooner or later. Okay, so I don't think I want to move into any new concept for today.
There's more.
Have I given you any questions to do? Not yet, right?
Wait, how about Chloe? I thought she come for chemistry.
Who?
Chloe.
Oh yeah, no lah, she left chemistry too.
Huh? When?
Just like 2 weeks ago. Since the last time you saw.
Huh, that was long time ago.
Okay, lah, I don't think I can carry on because a lot of new things already.
I want to ask, right,
Hmm.
if a balloon flies high up into the air, will it explode?
Explode.
How say? Like, you know the helium one, right? Then you let it go, then it fly high up.
Why will it explode?
Will it explode?
Maybe.
That's right. During the SP open house, right? One of my friends, right, his hands slipped, right? Then the balloon go fly up to the sky.
I think eventually it will.
Right.
Yeah, eventually. Or you just drop down somewhere. Hey, you all didn't get any free food on the day?
Oh, I'll take a.
No goodie bag.
No. No, they say got some free T-shirt or whatever.
Oh,
But then I also don't know where they go.
usually you have to queue up for those things on.
I want next year. It's okay.
Next year, next year you better make it a point to go.
Now, I'll go and tell you.
Yeah, lah. There's no year next year already.
Wow, good luck. Legit details.
But of course, because you have limited time, you can only choose to go to a certain one or at most two polys. Because every poly is having open house now.
Then it's like for 3 days.
Yeah, 3 days. Unless you have the time Thursday go here, Friday go there, Saturday go there.
Yeah, each day 2 poly.
Then you can try.
Then 6 polys in 3 days.
Well, each poly already costs so much time.
Yeah.
I mean, unless you know exactly what course you want to ask. Even FP, you can spend the whole day there. You have IT, you have chemical analysis, you have business, you have what engineering, architecture, all different parts of the poly.
Why SP so big? Man?
The oldest poly.
So it's the biggest one.
Yes. Yes.
Next year if I go, will you be there?
I could be. Depends on my schedule, whether I have lessons on the day or not.
Hopefully can.
Okay, that was for this.